Good day. In this video, we are going to try and solve question 2C part 3 of the 2023 NCEA Calculus Level 2 paper titled Apply Calculus Method in Solving Problem. This is an excellent question and I'm going to be doing it very slowly because this is a complicated question. So the question sounds like this. Okay, I'm going to adjust the paper so we got more space. Okay, so a car with brake pads is capable of deceleration of 2.5 meters per second squared. However, as the car brakes age, they become less effective at slowing down the car. If the oldest car's brake were only able to allow for deceleration of 2.1 meters per second squared, what is the highest speed in which the car should be traveling so that it is able to come to a complete stop in the same distance, approximately 154 meters, as the new car described in part 2. So we are going to let the highest speed for the car to come to a complete stop be equal to k, and that is what we are going to calculate. So we know that deceleration is 2.1, so we're going to put a instead of d. Acceleration is minus 2.1. Okay, so we need to find the velocity. So the velocity is the integration of that. So velocity is going to be v, adjust a bit, okay, equal to integration that is minus 2.1 t plus c. Okay, so we are going to let at time equal to 0, okay, we are going to let the c equals to k. K is the time when the car comes to a complete stop. So that equation now becomes v equals to minus 2.1 t plus k. Okay, so now we need to find what is the value of the equation. Okay, so now we are going to find the velocity. Okay, the velocity is now going to be that equation, so we're going to remember that equation because we need that equation to calculate the distance. So when v equal to 0, okay, velocity equal to 0, we need to know what is the time equals to. So we are going to calculate time in terms of k. To do that, we are going to substitute v equal to 0. So 0 equals to minus 2.1 t plus k. So to solve this equation, we're going to plus 2.1 t on both sides. So we're going 2.1 t equals to k. Okay, and so t is equals to k over 2.1. So we have found that velocity 0, your time is going to be k over 2.1. So remember that equation too. Okay, so now we are going to calculate the distance. Okay, remember we're going to use that formula. So the distance is represented by s in calculus. So it's going to be minus 2.1 t squared over 2, integrate that equation, plus kt plus c second c. Okay, or we're going to put c2. Okay, to calculate the C2, when we need to know time equal to 0, distance is always equal to 0. When the car is not moving, the distance is going to be 0. So we're going to put 0 equals to, this part is going to be 0 equals 2.1 times 0 is 0. Any number multiplied by t squared 0 is going to be 0. This part is also going to be 0. So C2 equal to 0. So your distance is going to be minus 2.1 t squared plus k. That's the equation of the distance formula. Okay, so now we're going to solve your k. Okay, so to find the k, we need to know this: when v, velocity equal to 0, your time we found earlier is going to be k over 2.1. Okay, and then your speed or distance, or not speed, distance is 154. Okay, so once we done that, we are going to substitute into this formula. Okay, so we're going to be, distance is 154. Okay, we're going to do slowly now, equals to, 2 minus 2.1 over 2. Sorry, because it's integrate. Okay, divide by 2, so it's going to be minus 2.1. Okay, your t squared is k over 2.1. Okay, and it's squared there. Okay, divide by 2 plus k, it remains as itself. Okay, k, and your t is k over 2.1. Okay, we're just going to substitute into the equation. Okay, we're going to simplify this. We're going to leave this on the left hand side remain. Minus 2.1 divided by 2 is going to be minus 1.05, and this part is going to be k squared over 2.1 squared, okay? And that part is going to be k squared over 2.1, okay? So now we're going to make the same denominator, okay? 2.1 squared, so we're going to square 2.1 this side, okay? So what happened can be minus 1.05 k squared over 2.1 squared plus 2.1, we multiply 2.1 on both sides, k squared over 2.1 squared. So simplify that, it's going to be minus 1.05, okay? K squared, okay? Plus 2.1 k squared, and the whole thing is going to divide by 2.1 squared, okay? So now is the tricky part, okay? So we're going to simplify this part. 2.1 minus 1.05 is going to be 1.05 k squared over 2.1 squared, okay? So 154 equals to that. And then we are going to solve this, okay? So what we're going to do, we're going to multiply by 2.1 squared on both sides. So 1.54 times 2.1 squared, I found out the answer. I bring it up a bit, okay? It's going to be 679.14 equals to 1.05 k squared, okay? So because this will cancel out, okay? So now we're going to do, we divide by 1.05, it's going to be 646.8. So k squared equals to 646.8. And to find your k, you square root that answer, and you can't have a negative answer. The answer is going to be 25.4 meters. So that is the whole process. It's very complicated. Go through one more time, I advise you, and you can answer that. That's excellent. These are harder excellent than the previous one, and hopefully you get it. Cheers everyone, have a great day.